Now let's look into the theorem. The statement of the theorem is, if a line is parallel to any one side of a triangle, DE is a line which is parallel to BC and is cutting two other sides of the triangle AB and AC in two different points D and E. If this happens, in that case, the divisions made by the line, the divisions are AD and DB, AE and EC are the divisions made by the line. These divisions are in the same ratio. That means AD upon DB is equal to AE upon EC. This is the statement of the given theorem. And we have to prove this. Do some construction. We are going to draw two perpendicular lines, DM and EN. These are the two perpendicular lines on the basis AE and AD. The purpose of drawing these perpendicular lines is we can consider these perpendiculars as height of the triangle ADE. DM can be height when AE is considered as base, and AN can be height when AD is considered as base. Means we can find out area of the triangle ADE in two different ways. The first way is area of triangle ADE is equal to base into height. It is the formula, we know this, it is a fundamental formula. And the first way of finding the area of the triangle ADE is half AD. AD is base and height is EN. This is the first way. And another way, again, half into base. AE is base and DM is height. DM is height. These are the two ways to find out area of the triangle ADE. And we have found that. Now let's turn to the another construction. We have joined B with E and C with D. Okay, we have got two triangles, triangle BDE and triangle DEC. We have got two triangles. And note that these two triangles are in the same parallel lines. And note that we have studied in class 9th. If two triangles are lying in the same parallel lines and on the same base, then the area of those two triangles is the same. Means area of BDE is equal to area of DEC. This is the theorem we have learned in the class 9th. Okay, for the triangle BDE, we can take BD as base and EN as height of the triangle. So the area would be half DB into EN, means base into height. Okay, we have found the area of triangle BDE. Now let's find out the area of DEC. Okay, in this DEC, EC is taken as base and height is DM. It is a perpendicular line. Okay, perpendicular line on base is considered as height. And area of triangle DEC is equal to half into EC base into height DM. Okay, we have found three areas. The area of ADE, bigger triangle in two terms. Okay, an area of two different triangles in between two parallel lines. We have found three areas. Now we have to take ratios of these triangles one by one. Means area of triangle ADE with area of triangle BDE. This is one ratio. And another ratio, area of triangle ADE with area of triangle DEC. See, area of triangle ADE with area of triangle BDE. This is one ratio. And what is that? ADE is equal to, we have found, half AD into EN, and area of triangle BDE is equal to half DB into EN. This is DB into EN. Okay, this is one of the ratio, and we have named it as equation 1. After cancelling the terms, we will get AD upon DB as the portion. Next, take a ratio of another. Take a ratio of triangle ADE with the triangle DEC. Okay, so half into A into DM from here, half into A into DM, and for this, half into EC into DM, half into EC into DM. And again, cancel out the terms which are getting cancelled. DM getting cancelled, half getting cancelled. The quotient would be A upon AC. This is equation number 2. In these two equations, we can see that area of BDE is equal to area of DEC. Because these two triangles are situated in two parallel lines and on the same base DE. Therefore, their area is same. So we can take BDE equals to area of DEC. We can substitute values over here. Means this value is equal to this value. That means this left side will become equals to this left side. Means both the left sides becomes equal. Therefore, we can take right sides equal. So AD upon DEB from this equation is equal to AE upon AC from this equation. We can take these two ratios equal. Therefore, we can say that it is proved that the ratios of the division AD, DB, AE and AC are in the proportion.